We will follow the three-step procedure to find a solution for this problem. Summarize, analyze, and work out the details. First, let's read from the beginning. The mass percentage of a typical saline solution is 0.90% sodium chloride, and the solvent is water. The density of the solution at 20.0 degrees Celsius is 1.00046 gram per milliliter. What is the mole fraction of sodium chloride in the solution? When we summarize, we need to write down the numbers with units, and what we are looking for. As you may have already noticed, I assign a symbol to every number with a unit. I also assign a symbol to what we are looking for. If you assign appropriate symbol to the numbers with units, it will be easier for us to find the equation to use. Let's conduct some analysis. Let's say what kind of calculations we need in order to find the solution for this problem. Here shows the percentage of sodium chloride. Let's look at the definition of the percentage of sodium chloride first. The percentage of sodium chloride is defined as the mass of sodium chloride divided by the mass of the solution, which is the total mass of sodium chloride and water, multiply 100. Then let's look at the definition of the mole fraction of sodium chloride. I use 3 lines to represent this is the definition. Then let's look at how can we convert from here to here. Remember what we learned in class. When you convert from one concentration to another concentration, you can assume you have any amount of the solution. You can also assume you have any amount of the solute. You will get the same concentration after the conversion. If you do not understand this assumption, you can watch my previous video. In this case, if we assume the mass of the solution is 100 grams, our calculation will be very, very easy. Let's assume we have 100 grams of solution. This is kind of crowded. Let me rewrite this equation in a different place. And also, we want to plug in the numbers. If we assume we have 100 grams of solution, we can easily calculate the mass of sodium chloride. And if we know the gram of sodium chloride, we can use the molar mass of sodium chloride to convert to moles of sodium chloride. And if we know the mass of the solution, we know the mass of sodium chloride, we can calculate the mass of water. And if we know the mass of water, we can calculate the moles of water. After we find the moles of sodium chloride and the moles of water, we can calculate the mole fraction of sodium chloride. This is our step 1. And this is our step 2. You can also call this step 2, since we already called this step 2, so we will call this step 3. And then this will be step 4. And then this is step 5. And step 6. Now let me show you the details of all steps. As you can see here, each step is extremely simple. Step 2. We will find the mass of water. Well, we cannot find the mass of water unless we know the mass of sodium chloride. So this should not be step 2. Okay, step 2. We will find the mass of sodium chloride. Step 3. We will calculate the mass of water. Step 4. We will convert the mass of water to moles of water. We need to calculate the molar mass of water. Step 5. We will calculate the moles of sodium chloride from the mass of sodium chloride. Similarly, we need to calculate the molar mass of sodium chloride first. Now we will plug the moles of sodium chloride and the moles of water into the definition of the mole fraction of sodium chloride. The answer we get is 0.0028. The mole fraction does not have a unit.